Good morning, good afternoon, dear viewers, friends, and colleagues. Welcome to the Innovative Sustainability channel. Today we have a guest. It's Dr. Bonny Banerjee. He is joining us today from Memphis, Tennessee, USA. He is co-founder of the Attention Labs, and he's also associate professor with the University of Memphis. Before that, he received his master's in science degree at electrical engineering and PhD in computer science from the Ohio State University, also in USA. And then he led the research in the multiple startups and in academia. He holds 8 patents and he published over 75 peer-reviewed papers in reputed venues in the areas of artificial intelligence and cognitive science. So it's my pleasure to have you here, Dr. Bonny. The floor is yours. I know, first of all, welcome to the channel. I know you have slides to share, so please start.
Thank you, Marina, for that introduction. And let me start by sharing my slides.
Excellent. Okay. Excellent. Full screen. I can see that. Good.
Okay, just a moment.
Mhm.
Okay, you can see the slides now?
Yes, it's just 2 of them appear, so somehow has to be the full screen. Like that. Perfect.
No, just a moment. Okay, do you see the slide full screen now?
Yes, the slide and also the next slide. That's how it shows
Okay,
up.
what is happening? Just a moment. Do you see the full screen now?
Now, yes, full screen. All good.
Okay, good.
Good.
Okay, so I'm going to talk about sustainability of artificial intelligence. Artificial intelligence is my field, and there has been a lot of discussions, a lot of talk about the future of AI, and going as far as to say that it can take over the human race, and it can be detrimental to the environment, to the society in many ways. So we're going to touch upon some of those that are related to sustainability. The invisible cost of intelligence and the innovations that can save it. That is going to be the topic of the discussion. So first we start with what is sustainability in AI. Is AI quietly heating the planet? So let me start with something uncomfortable. Every time we ask AI a question, every time we generate an image, every time we train a new breakthrough model, energy is consumed, water is used, servers heat up. And here is the paradox. The very technology we hope will save the planet may also be accelerating its stress. So that is the tension I want to explore with you today.
Yes, something we don't think about. Yeah, normally we don't think about. Yeah, it's a good topic.
According to the International Energy Agency, data centers already account for a significant share of global electricity usage, and AI is one of the fastest growing drivers. Training one frontier model can consume as much electricity as a small town over weeks. And that's just the training. Inference, answering our daily prompts, continues forever. This is not a niche problem, it's infrastructure scale. We are in an AI arms race, bigger models, more parameters, more compute, performance improves, but so does energy demand. What if we are optimizing the wrong variable? What if the future of AI isn't bigger, but smarter per watt? Sustainability in AI is not just about electricity. It means environmental sustainability, which includes energy, water, rare earth materials, economic sustainability. Can businesses afford to scale AI responsibly? Societal sustainability. Are we building systems that strengthen the society? Sustainability is not a constraint, it's a system design challenge. There are multiple approaches that have been put into place to foster sustainability. Now, to most people, AI feels invisible. We interact with AI using a chat window typically. There is a smart assistant, a recommendation system, but behind that simplicity are enormous power-hungry data centers filled with specialized chips, cooling systems, and complex infrastructure. The magic is virtual, the footprint is physical and very real. For years, AI performance was evaluated on a few metrics, such as accuracy, speed, capability. Now a new metric is emerging: performance per unit energy usage. The companies that win the next decade will not be those with the largest models. They will be the ones with the most efficient models. Major technology companies are redesigning data centers to run on renewables, using advanced cooling, even submerging servers in liquid. Models are being compressed, pruned, distilled. Instead of retraining giant models from scratch, we fine-tune existing ones. Reuse instead of rebuild. This is the beginning, but it is not enough. The real innovation is not scaling compute, it is scaling efficiency. Smaller models trained smarter, task-specific AI instead of universal brute force, architectures designed to minimize waste from the very beginning. Sustainability must become a design principle, not an afterthought or a patch. Let me give you one example. In heavy industry, building and testing physical prototypes cost materials, energy, and emissions. Now imagine creating a digital twin, a virtual replica of a plant or process. Engineers simulate thousands of scenarios before touching the physical world. Less waste, fewer failed experiments, lower emissions. AI here does not consume, it prevents consumption. This is sustainable intelligence. However, if to run the digital twin, which might involve a lot of AI and machine learning, we use up a lot of resources, a lot of energy, then AI is not really sustaining. It is the consumer. It is consuming more than it is sustaining. In healthcare, AI accelerates drug discovery, reducing failed test and wasted resources. In food systems, precision agriculture reduces fertilizer and water use. In mining, predictive maintenance reduces catastrophic failures and material loss. In energy grids, AI balances supply and demand dynamically. AI is not just a consumer of energy, it can be a multiplier of sustainability across every sector represented in this room. Getting into a little bit more details, drug discovery is one of the most resource-intensive processes on Earth. Thousands of molecules are synthesized, most of them fail. Years of lab energy, materials, and human effort are lost. Now, AI models, such as those developed by DeepMind, can predict protein structures with extraordinary accuracy. Instead of physically testing thousands of possibilities, researchers can computationally eliminate most of them before a single chemical reaction occurs. This means less lab waste, fewer failed experiments, faster delivery of life-saving drugs, and sustainability here is not abstract. Every failed trial avoided saves massive material and energy investment. This is intelligence replacing waste. Agriculture feeds the world, but it also consumes enormous resources: water, fertilizer, fuel. Traditionally, farmers treat entire fields uniformly, but fields are not uniform. AI-powered systems like those integrated into modern agricultural machinery analyze soil, moisture, and plant health in real time. Instead of spraying everything, they spray only what needs treatment. The result? Less chemical runoff into rivers, lower fertilizer waste, higher yields with fewer inputs. This is sustainability at planetary scale, and it is powered by data and intelligent optimization. In the heavy industries like mining, the scale is staggering. Gigantic haul trucks burn thousands of liters of fuel per day. Processing plants consume immense electricity. Now imagine improving efficiency by just 1%. That may sound small, but at industrial scale, 1% can mean millions of tons of carbon dioxide avoided annually. AI enables predictive maintenance, which is fixing equipment before catastrophic failures. Optimizing routing, which involves reducing idle time, and real-time energy management. In these sectors, sustainability does not require revolution. It requires intelligent optimization, and AI is uniquely suited to deliver that. So now, looking at the future, there are two futures to choose from. One where AI grows recklessly, and one where AI grows smartly. Same ambition, different philosophy. The difference is intentional design. The most exciting frontier is right in front of us, is the self-optimizing systems. AI that automatically searches for the most energy efficient architecture. AI that schedules its own training when and where cost of energy is low, such as at night, and from renewable energy sources. AI that continuously compresses itself. This is not science fiction, this is active research. The next leap in sustainability may come from AI machines improving their own sustainability. If we measure only accuracy, we get larger models. If we measure efficiency, we get smarter models. What gets measured gets optimized. We must require transparency in AI carbon footprint. We must design hardware for reuse and recycling, and we must reward companies for efficiency and not for excess. So we should choose to change the metric. So efficiency must be a mandatory benchmark. Carbon transparency, circular hardware lifecycle, and incentives aligned with sustainability are mandatory. The greatest risk is not AI becoming too powerful. The greatest risk is AI becoming powerful without responsibility. Technology has always shaped civilization, and now it is no different. However, the difference is in the scale and speed, and hence responsibility plays a major role. In closing, I would say that we stand at a turning point. Artificial intelligence may become the most transformative force of our century. But the real question is not how intelligent can we make our machines? The real question is, can we make intelligence itself sustainable? If we succeed, AI will not just optimize businesses, it will help protect our planet. And that is innovation worthy of the next generation. Thank you.
Thank you very much. It's a very exciting topic. Lots of things you said is new, even like overheating. So if you don't mind, we can maybe travel back a little bit to the slides. I just want use time maybe to briefly comment. Like when you mentioned overheating, I think it's not really something that all of us consider every time we ask Copilot or Gemini or whatever AI tool is available. But I think when you
Yeah.
showed that every request has actual physical footprint, I think it's slide number 3, if you kindly return to that, just to give a visual to viewers. It's makes you think how often you want to do it, and maybe how efficient you have to ask the question. Not just every random questions that pops to mind, but also ask it intelligently in a
Yeah.
sustainable manner. So this is for me personally, it's like not refresher, it's just realization, I imagine. And for many viewers could be the same way. So I think it's a very important point that you touched and brought forward today.
Yeah,
Sure.
so I would like to mention regarding that these large language models like ChatGPT and other ones
Mhm.
have become so good that people like to talk to it. They have a relationship with these LLMs. They consider them as their friends and so on. And these LLMs are really that good. However, when you talk to them just for entertainment purposes, we are using a real footprint, and that we don't really realize. So it is, I mean, we are at a point in the human civilization where we have developed something that is extraordinary, especially these large language models and AI in general. But again, the responsibility of not getting harmed due to these technologies is something we have to always keep in mind.
Another thing you mentioned is that the companies who will win would be a performance measured per unit of the energy usage. It's really something new as a concept, as the understanding. So I guess if you, yeah, you can stay maybe at the, yes, like in radical innovations, what must change. Yes,
Yes.
if we can
So
talk about it, yeah. Mhm.
right. So the companies they build these models, and of course the field of AI has been traditionally geared towards rewarding accuracy
Yes.
and they were less concerned about efficiency, but now the concern has increased. And now when we see papers published in the top journals and conferences, we see that there is an analysis of the efficiency of the model or the size of the model and all of that included in the paper, which is the right direction, I think. And so if this continues, and if every researcher, every company, every university, every lab takes this into account when developing their models, then there is going to be a significant change, and we will see smaller models working well, and maybe working as well as larger models that we have today.
So in smaller models, you mean more specific to the topic, right? More specific to the task, or even the niche of application, like I
Yes.
don't know, pharmaceuticals, for example. It's very specific niche where you have structures, right, existing, um, and I don't know. Maybe you can touch like what specific models people normally use to understand the which
Okay.
graphs, which structures to use, how to use them, if you can work out.
Right. So the machine learning models that are used are extremely large models. They can be different kinds of models like transformers and many other kinds. And so these are the ones that are actually used are very large, and they are run in thousands of GPUs. And these models, so in many cases, real-time performance is not required. So then the size of the models do not need to be small, or the models do not need to operate as fast. So that allows these companies or these labs to run very large models. So that leads to waste. But at the same time, in healthcare and pharmaceutical, that's a very critical industry where people's lives are saved by discoveries and inventions made in those industries. So this is required, but we can come up with certain responsible ways of
Hmm.
developing the infrastructure for handling problems in these industries. And also, as the AI machine learning models become more efficient and smaller in size, they will be taken to be used in the healthcare and pharmaceutical industries. So then that industry will automatically become more efficient. So I think the instead of focusing on particular industries, I think it is more important for the field of AI to develop efficient algorithms. When algorithms are efficient and they work well, then they will automatically be taken and used by the different industries.
I see. So it's within basically AI to be efficient within the calculations, the processing information at its end, and then have specific applications that, like you mentioned, for
Yeah.
healthcare, or you also mentioned, I think, mining industry. I think it's great that AI is kind of penetrating that because it's one of the oldest industries, and we always think about that associate lots of waste, physical waste, I mean, because what they mine is only small percentage is the goods.
Yeah.
The rest is usually disposed, but nevertheless, it's a different topic. It's more, um, I guess, to talk about processing itself, chemistry around it, and how to mine more efficiently. But I think AI can help visualize that. And I think another
Yes.
topic you mentioned when you said responsible usage, that something that occurs or comes to mind is the ethics about it. I think we're just learning, right? It's coming so fast to our life in every field
Yeah.
we touch that definitely at some point it has to be ethics about it, and
Yeah.
training, so that people who use it, they have some structure behind it, meaning certain behavior is expected from all of us when we operate the systems, so that it becomes a systemic and not just very random when collectively we generate waste and contribute to the heating of the planet.
Yeah. Yeah, I agree. And like I just said, so if the field of AI starts producing efficient models and efficient algorithms, then the other fields that use AI, they will become efficient kind of automatically. Of course, they have a responsibility to handle, to use AI efficiently as well. Uh,
Right.
but uh, but since they are the users mostly and not the
Mhm.
developers, so the main responsibility lies in the field among the people who are working in the field of AI and developing these models and algorithms.
Yes, but otherwise, the examples that you mentioned, especially I can relate to pharmaceuticals because I worked in vaccines for many years, is the fact that, to reduce the failure rate by choosing correct targets or predicting the structure to going more with known, even though we still will face collectively lots of unknown and clinical trials can always bring surprise. But nevertheless, if it's more intelligent approach, there is a possibility to be more strategic and generate less waste, lose less money, and be more efficient in the drug development, actually drug manufacturing. One
Right.
more
I,
question. Yeah, go ahead.
yes. So I completely agree. Yeah.
Another question that I was wondering, you mentioned how the AI systems can make themselves more efficient. Any thoughts about it? Like just, for people who are not
Yes.
very
So
familiar, how to visualize that. Yes, yes, if you can.
okay. So my slides emphasized one particular thing.
Mhm,
If that is going to be the take-home message, is going to be the performance metric, which
mhm,
is performance per unit energy usage. So it is not just performance, so not just accuracy, not but it is or whatever accuracy is one of the performance metrics, but whatever it is, so it is that performance metric per unit energy usage. So if that is how we start evaluating our models, then I think the models are going to be automatically more efficient in terms of energy usage. And people working in the field of AI will be motivated to develop algorithms which are better in terms of that metric. So that metric is what I am
mhm.
emphasizing here is going to make a big difference if it is adopted widely in the field.
Great. So the metrics come from the energy usage, unit of energy usage. So that's the criteria that you want to
Yes,
measure. It's like the KPI almost, right? For the
exactly.
AI models to
Yeah.
prevail and potentially, to contribute to the fund fields. I think
Yes.
it's great. Yes. Any closing remarks before we stop? I think we're good in terms of time, but just to wrap up.
Yeah, so this is something that I think everyone should be thinking about. They
Mhm.
should not be just concentrating on getting the best performance. And I think the responsibility of doing this can lie a lot on the venues that
Mhm.
publish the research coming out of researchers in AI machine learning from all over the world. So that is what I would like to say. So these venues should be, meaning journals and conferences, should be looking at this and should be imposing some criteria on how models and algorithms should be evaluated.
Got it.
That's
So
all.
that would
Thank
be
you.
opportunities and also potentially maybe the conference, just like in pharmaceuticals, we'll have international conference of harmonization. So potentially,
Yeah.
something like that may be already happening, or, should happen as the alignment globally, right, between the researchers, just as a guiding principles for the users
Yeah.
of the AI. That would be helpful and maybe eye-opening for many. Dr. Bonny, thank you so much for joining today. It's a really great topic, very interesting. Everybody talks about that and uses it, but we never really think and visualize that deep like you presented today, because there are, every field has their peculiarities, and I think the purpose of the channel is to introduce this, to make people aware, because all the responsibility starts with awareness. But once you're aware, of course, the next is, okay, so have to act upon it. So I think, take home message for me, if you ask question, ask it intelligently, so it's useful and not just wandering around. And, just by the way, it has to be purposeful, meaningful, and has to have a serious use. Then, AI use, at least even, like for Copilot, for example, it could be then understood and, have real value. I think that's great that you described it today and gave so many thoughts to take home message. Okay, thank you. Thank you very much. I hope you will join the channel again. We can, talk further. I think digital field is big and it's a lot to talk about. And yeah, thank you again for your contribution today.
Thank you,
Thank you.
Marina. Thank you.